Okay. So if you go to grades, one thing I don't want you to be worried about is I'm not having Canvas calculate grades because there were a lot of assignments that I put up that a lot of you guys had already turned in. So it could say missing, but it isn't really missing because you turn it in over email, you turn it in before the pandemic hit or whatever. Is everybody with me? Or is anybody not with me? Okay. Pixel 3, who is that? Let me see. Could everybody please, if I have to say this every time, it's gonna get crazy, but when you log in, you need to put your actual name in. If you hover, so go to participants, hover over your name, and then you can hit more and you can rename yourself. If you need some help, let me know. So for example, Pixel 3, I don't remember having a student named Pixel. iPhone, I think that's Hayam. Is that Hayam? Or is that an iPhone that just has become sentient and wants to learn enough math to take over the human race? I think it might be that one. Hayam, are you out there? Or who's iPhone? And who is Pixel 3? Who are you? I need people to work with me. What is happening? Is my internet still on? All right, Pixel 3 has left. I think they were an interloper. iPhone, I'm pretty sure that's Hayam. Hayam, are you out there? I think it is. All right, this is gonna.
Yes, yes.
Okay,
yes.
okay. All right, I'm gonna help you out.
I say yes, but I'm mute. I forgot to mute.
I'm gonna rename you real quick. Hold on, where'd you go? I have that power. You are now Hayam.
Yes.
Okay. Thank you. Sorry, everybody. Let me see. Everybody else looks good. I can see your names and I know who the hell you are. Good. All right. So, oh, everybody mute. Mute it up.
Okay.
All right. So right now you should be seeing Canvas. If you go to grades, number one, don't freak out if it says incomplete or whatever. I'm not letting Canvas keep track of grades. That's how you turn stuff in, and then I put it in my spreadsheet. But the thing I added recently is called overall average right here. There's one called overall average, and I just typed in your current average straight out of my spreadsheet. So if you go to Canvas, click on grades, find the one that says overall average, and that's your overall average right now, not counting homework because I take homework until the day of the final. So does there anybody not understand what just happened? So if you want to know your current average is, go there. I will try to keep it updated. Maybe I should put like a date in there, the last date that I updated it. I'll do that next time I update it. I'll put the date that it's updated. Okay, everybody good? All right, I'm gonna take that as a yes. Let me see. So let me see if I could do this. First off, anybody have any questions from homework stuff? All right, if you click on pages in Canvas, do you see this practice test 4 up here? See how it's in quotations because we don't have a test 4. We're actually going to kind of look at this today. Here's what it looks like. Right, some yummy stuff in there. Okay, so I kind of want to go over this a bit. I want to let you guys work on some problems. Tomorrow's quiz is on 65667. Right, so that includes dividing by monomial, dividing by a binomial, and then scientific notation, negative power stuff, right? So let's start with, if there's no questions from anybody, homework questions or otherwise, not seeing anything. All right. So look at this. Look at this problem. Let me zoom in on this bad boy here. Let me see here. Get over here. Look at that. Look at that monstrosity. Let's start with this one. Before we try to tackle that one, let's do this one. Part F. All right. Anybody not see part F? Is everybody with me? So part F says 6x to the 8th over 15x to the negative 4th. There's two ways to do this, and I'm going to show you the way that I suggest you always do it, but then I want to show you that it still works if you look at it a different way. Do you see how if I cover the x's, I just get 6 over 15? So I would just do that like I always do. I would just reduce that. How does 6 over 15 reduce? Oh, this is going to suck a little bit. Oh, well, too bad. Let me see if I can't make this work. I'm going to make this work. I really am. All right. 6 over, oh, Veronica, change your, what's happening? Oh, is Veronica trying to, I don't know what people are doing out there. Is everybody okay in the chat? Everybody, what's happening? Okay. So we're looking at this right now. 6 over 15. How do you reduce that? What goes into both of those? 3 goes into both of those, of course, right? I have to use my iPhone. Okay, you're okay, Veronica. I don't know what's happening out there. You're fine. Okay. All right. All right. All right. Today is just a weird day. So yeah, if I reduce 6 over 15, I get 2/5. So far that's what we got, right? Now watch. 2 ways I can do that X. I'm going to do it the way that I really want you guys to do it first, and then I'll show you kind of like a shortcut, but I'll show you why the shortcut is scary. What part of this wants to move? I mean, what part of that doesn't like where it is? This might be a weird way to say this. Yeah, the negative 4, right? Anything to a negative power wants to flip. So those 4 x's right there, they want to come up. So I'm just gonna do that. So on the top, I'm gonna have those 8 x's still there, x to the 8th. You got to forgive me for the little, I can't do exponents like normal on here, okay? But then those 4 x's, let me get out of the way. Those 4 x's also come up. They're to the negative powers, then they want to flip. And they're the only things that flip. So I'm next to this, I'm going to put the x to the negative 4. I mean, sorry, x to the 4th. There it is, Jeff. So those 4 x's come up. Let me kind of make my, Jeff, all right, dude, just do it. Okay. There, let me make my little thing a little bit. There you go. All right, let me stop for a second. So the 6 over 15 works the same way it has forever. Why the hell would that change? It cannot change. You just kill the 3 in both, reduce it, right? Negative power means flip. So you flip anything with a negative power. Now, how many x's do I have up top total now? How can we write that in a better format? What do I have? How many x's do I have on the top now total?
12.
12, yeah. There were 8. 4 more came up. So now I've got 12. Let me see if I can recreate this. Okay. No. There. Okay. Bam. All right. That is going to be annoying. There's just no perfect way to do that. Oh, well. So look at part H real quick. I'm going to skip part G for now, just because. Look at part H. Can anybody identify how many things in part H need to be moved? They don't like where they are. I'm going to move that monitor somewhere better. Let me do this. can see it. Okay. Anybody? So part H, the one with the 55 stuff?
The negatives.
Yeah. So how many?
There's 3.
3. Cool. That's all I want, right? Everything to a negative power doesn't like where they are. That's why they're negative. So they want to flip. So negative power means flip. So those 2 B's are going to go down on the bottom. Wow. Those 3 B's are going to go up top. Wow. And then these 2 A's are going to go up top. So that's just a big ugly mess in it. So I'm going to kill it. Go away. That was just gross. So those 2 A's come up. Those 2 B's go down, and those 3 B's go up. Let me just stop right there, because that's what a negative power means. So let me just do that. And the reason I do that is because what are the things in basic algebra that really kill us the most? 0 and negatives. So if I have a property of the thing I'm looking at that lets me rewrite negatives into positives, shit, yeah, I'm going to do that, right? I'm sorry if there's any kids out there. I can't see any kids. So yeah, I'm going to do that because then I'm not going to make a negative mistake, which is a really easy mistake to make. So let me just do that. Let me rewrite what we just said. You set up a little fraction bar. Weehaw! It's just the thing I got to do to make this work. So I'm not going to worry about the numbers yet. Let me just rewrite the 55. Those 5 A's like where they are, right? Those 5 A's like where they are. Those 5 right there, they want to stay. Those 3 B's are coming up. Oh, somebody else is here. Those three B's came up. There they are. And those 2 B's went down. So I'm not going to worry about them. Oh, I should have put the A's next to it. Those two, let me see. Those 2 A's are going to come up. Let me scoot them in here so they're next to the other A's. So the A squareds come up, the B cubed comes up, and the B squared goes down. So the C cubed is still up there. Let me stop for a minute. I know that formatting sucks. I'm sorry. I can't draw, type, and get good formatting all 3. Right, I've got to give one of those up. Let's see. Yeah, okay. So again, those 2 A's came up. There they are. Those 3 B's came up. There they are. Those 3 C's like where they are. They stayed. There they are. Those 2 B's went down. Let me type the bottom out now. Let me type down here. Okay. So I'm going to put the 15 there. We're going to worry about it in a minute. I lost those 2 A's. I lost those 3 B's. But those 2 B's came down. And then I still have those C to the 7th down there also. Okay. Let me stop there. It's probably the worst way to type this out, but I don't know what else to do. All right. Can you guys see that? So 55, A to the 5th, they're still up there, but now the A squared came up, the B cubed came up, and the C cubed is still there. That's what the top is. So on the bottom, those 2 A's went up, those 3 B's went up, and the 2 B's came down. That's what's on the bottom now. Okay, let me stop for a minute. So that's the way I would do that kind of problem, is find my negative powers and move those immediately. And now look what I have left. I have something that's not that horrible of a problem, believe it or not. 55 over 15, what goes into both of those?
5.
5, so I get 11 left up top and 3 on the bottom. Okay. How many A's do I end up with on the top?
7.
7, right? 5, and then 2 more came up, so now I got 7. And then, let's see, what about the B's? Let's see what happens here with the B's. How many B's cancel?
2.
Yeah, 2 cancel, so there's 1 left up top, or you could do 3 minus 2 is 1, because we're dividing like bases, so that'll be B. Okay, I like it. And then what happens to the C's? That's very interesting. Where are there more C's?
The bottom.
On the bottom. So 3 cancel, there's 4 left, and they're going to be on the bottom because that's where there were more of them. So the 4 that are survivors are surviving on the bottom. All right, let me get that out of the way. Let me move my fraction bar over. There we go. Okay, I like it. Maybe. Let's see. If I use, wait, where am I at? Yes, okay, good. Youngsha, so that's what I forgot to say. Exactly. Looking back, let me erase this for a second. I said I would say this and then I forgot. What's the rule when you divide like bases? What do you do with the powers? When you divide like bases? Like,
Minus.
yeah, I subtract, right? So what is 8 minus, see that? I want to point at it and you guys can't, so I'm sorry. 8 minus negative 4 is 8 plus 4 is 12. Bam, there's another way to get that 12. But it's really easy if you're trying to do that in your head to get the negatives confused and to not change them correctly. And real quick, does anybody see, now watch, this is so flippin' cool. 8 minus negative 4, don't the negatives cancel? Right? So the negative becomes a positive. When we moved the 4x's up, that still made the negative become a positive, didn't it? So the visual of moving them up matches the algebra of subtracting a negative. Maybe. I know it's weird. But it's so flippin' cool. It's so nice to see that. So I know I subtract powers when the bases are the same and I'm dividing. I know I do. So 8 minus negative 4 is 12. So any other approach I have to doing it better come out with 12 because I know that's the answer. So if the numbers are negative, be very careful, Curtis. Be really clear with your question. If the exponent is negative, you move that thing up, right? A negative number never meant move it somewhere. Yeah, the exponent. I knew you probably meant that, Curtis, but you got to be really careful with how you say it because your brain hears what you say and it takes it off and goes crazy, right? Okay, your brain's always listening. I know. All right, let me see. Anything else here? So what would this be? Part B up here. So the way I look at part B, so this kind of thing can be on the quiz tomorrow because the last section dealt with negative powers. So I look at this exponent as 2 commands. I have 2 things to do. It's negative. The power is negative. So what does that mean I need to do to 3/5? Yes, I need to flip it. Is everybody with me? Because negative power means flip. Negative power means flip. Negative power means flip. So then once I flip it, I still have to square it. There's also a 2 up there. So I see that as 2 commands. Negative means flip, 2 means square. So I got to flip it and then square it. So the way I would do this is I would flip it. So now let me just do this the quick way. 5/3, right? I flipped it and now I still have to square it. And what do you get when you do 5/3 squared? Well, 5 squared. Yeah, go ahead. Sorry.
25 over 9.
Yeah. 5 squared is 25. 3 squared is 9. Kabam. So normally I like to, if I see a negative power, I take care of that immediately so I don't make a mistake with it later. I like to make all my exponents positive so I don't make a negative mistake. So I just do that. I like it. Okay, maybe. Okay, let's see. Oh yeah, here's the other stuff. So why don't we do this? Take a minute, and I can't see you. I can't really see most of you guys, so I don't know what you're doing. But please try to do part I. Try to do this. Let me see. In the meantime, I'm gonna see if I can't get a better way to do. Here we go. Perfect. see what happens if I do this. Larissa just can't stay in here. What's going on? Oh, no, am I? I am. Okay, good. Thank God. Had to make sure I was recording this. All right, I'm going to switch over just so I can write this in a better format. Let me stop sharing for a second. I'm in space. All right, where'd you go? There it is. All right. All right, so I should be able to, so you guys see it again now? Okay. So now that I got it in Word, I should be able to make better formatted stuff. Let me see. So first step on this problem. All right. Come on. You're going to work. You are going to work. You really are. What happened? There it is. Okay. Oh my gosh. Okay, give me a minute. My computer's really not liking this. Hold on. Get over there. All right, I'm not sure what you guys can see at the moment, but what's the first step in this problem?
Divide.
Okay, and what do you mean by that? So you mean, and again, I have no idea what you guys can see right now.
When you want to
Oh,
get
shit.
all, oh, sorry.
Sorry, Curtis, go ahead.
I was saying you kind of do each one step by step, like 24 over 6, 12, negative 12 over 6, and 8 over 6.
Yeah, I see what you mean. Let me make sure that we're talking about the same thing. Whoa, mute yourself. All right. All right, like that. Can you guys see that all right? Let me zoom in a bit. Right there? Is that cool?
Yeah, I do it like that.
Yeah, beautiful. And then you just take
We
each
divide
piece
it.
and yeah, simplify it. 24 divided by 6.
Is 4. See.
Let me see if I can't. All right. Oh, screw it. Let me see.
What?
Yeah, 24 divided by 6 is 4. How many C's do I have left?
4. C is C3. C cubes.
No.
No?
You had 2 C's and I'm dividing a C away.
Okay, then have just 1 C, you mean?
Totally. Yeah, because when you divide, you subtract. Why? Because when you divide, you lose some of those. C squared on top is 2 C's multiplied. Divide a C away. Now I have 1 C left.
Okay, we divided.
It's only when I multiply that I get more of that thing. When I divide, I lose that thing. And then the same thing with the D's, right?
Yes.
Okay.
But now
So I got that for the first piece.
yeah, I got 2 C.
Good. All right. So let's see. Then I have minus 12 divided by 6 is 2.
2. Yeah, I got 2.
The C's cancel, right?
Yes.
And then how many D's are left where?
Um,
I'm not sure why I'm
Yeah.
yelling at you guys.
1.
Where? I'm still yelling at you guys. I'm sorry.
In the top. We have to put in the top.
Why?
Because the 2 and the over D.
So for the middle term, where are there more D's? Where are there more of them? In the middle term, where are there more D's? On the top
In
or
the
the bottom?
bottom.
On the
We have to
bottom.
put in the bottom.
So any survivors are going to be there.
First C in the bottom D.
What do the C's do?
Cancel.
Cancel. So you get that.
Yes.
And then you got
Like that.
plus.
Yes.
Yes.
Like that.
Let me take this last guy.
But now I confused with the last one.
Hold on. Let me get this. Maybe this is not the best way to do. There's no best way to do this. This is going to drive me crazy. So what's going to happen to the last one? Hyam, can you mute yourself? What's going to happen on the last one is the 8 over 6, I reduce it like always, right? So that's 4 over 3. And then how many C's are left?
1
Where?
in the top.
Top, because that's where more of them were. And then nothing's messing with those D's, right? There's no other D's to kill those, so they just kind of hang out there. So it looks like that. So the 8 over 6 became 4 over 3. 1 C canceled, so you have 1 C left. And the D's, nothing changes those. There's no other D's in the whole problem, so they just stay there, D squared.
Excuse me?
Yes.
I don't understand how you do 4 over 3.
How do you reduce 8 over 6? What goes into both 8 and 6? Do you see the 8 over 6, that part right there?
Yes.
Okay, so that's just 8 over 6. How do you reduce 8 over 6? What goes into both?
By 2?
Yes, so then 8 divided by 2 is 4. 6 divided by 2 is 3. So 8 over 6 becomes 4 over 3.
I got it. Thank you.
I got you. Okay. In fact, let me show you something. I'm getting tired of this. Let me change to my, let me get rid of my asteroids. Get out of here. Okay. All right.
Yeah, please. Thank you.
Yeah. All right. In fact, let me see. I didn't really have this set up for this, so just give me a minute. Dun, dun, dun. Here's my special thing. And then I put you up here. Okay, I'll stop singing. All right. So watch this. It's kind of cool. So how would I do this, for example? A to the third divided, well, let's see. I want to be a little bit more interesting. A to the fourth divided by A divided by A, sure. I guess that's slightly interesting. What would be left?
3?
Yeah, because again, this is A divided by A. So of course 1 cancels, 3 are left. That is why it's subtraction, because the idea is related to what subtraction means. I have a process where when I have some and I do the process, I lose some of these. That's subtraction. I had 4, I'm dividing 1 away. So of course there's 3 left. Now,
Yes.
watch, everybody ready? What is 16 divided by 2?
8?
That's incredible, right? That's crazy. So watch this, watch. Now watch, people are like, but they don't work the same. Yes, they do. Yes, they do. What is 16, isn't it? 8 times 2? Right?
16.
16 is 8 times 2, right?
Yes.
And 8 is 2 times 4, and 4 is 2 times 2. So watch. 16 is 2 times 2 times 2 times 2, isn't it? I'm not suddenly telling you to do 16 divided by 2 in a different way. I want to show you that what we do with these is what we would do with numbers if numbers were written in exponential form. So watch. What is 2 times 2 times 2 times 2? 2 to the 4th. So now it looks exactly the same, doesn't it? So how many 2's do I have left? I have 3, because I had 4, divided 1 away. So now I have 2 to the 3rd. And what is 2 to the 3rd? 2 times 2 times 2.
8.
8, which is, of course, what 16 divided by 2 is. Now, what I really, really love is my students that look at me and say, are you trying to show us a better way to do 16 divided by 2, Jeff? Because that's shit. I knew it was 8. And that's not what I'm trying to do here. I'm trying to show you that numbers will work like variables do if we write them in the same format. The problem with this is, can I write, what is A times A times A times A? I don't know, but what is 2 times 2 times 2 times 2? 16. So that's why these look like they act differently, because I can go further with numbers. But if I write numbers in exponential form, the same rules will apply. All right, I like it. Now, nobody asked me that question, but I'd love to show that.
I got it.
Okay, it's just neat. Does it immediately help you? No, but it's part of the whole thing to make the whole thing make more sense, I'm hoping. Okay, maybe. So anything we learn that variables are supposed to do, numbers have to do the same thing, or else it's shit, because variables are numbers. Okay, and please, dear God, I'm not saying do all this. You know 16 divided by 2 is 8. Right, I'm never going to say to do all that. Okay, let me see. Let me put another problem up here. Do we, all right, before I get into any new stuff, anything you guys have as a request for tomorrow's quiz that you want to look at? Tomorrow's quiz, again, is on the part I thing we just did, dividing by monomials, the one we did divided by 6cd squared, that one we just did. It's the long division of polynomials, right? And then it's the negative powers and the scientific notation stuff. Yeah. Anybody want to look at some scientific notation examples? Okay.
Do example for like the yesterday. Please.
Yeah, scientific notation, right?
Yes, right.
All right, now watch. So remind me, how would I write that in scientific notation? What's the shortcut we can use now? It's how many times to move the decimal. But can you tell me right now, will it be a negative or a positive power?
Negative.
Good, because it's a small number. So it's going to be 1, 2, 3, 4, 5. You always want to move the decimal until it's after one digit. So it's going to be 3 times 10 to the negative 5. I like it. I like it. So negative power means a small number. A small number means a negative power. I like it. So if I had 14 billion, what would that be? Well, let's see. Is everybody cool with these? These are grouped so beautifully. Here's the decimal to start with. Is everybody cool with that? I sometimes get people not understanding when the decimal doesn't show up, it's at the end. It's a whole number then, right? So then 3, 6, 9, 10.
10 zeros.
Mommy! Do you guys see that?
I'm sorry, yes.
So the power keeps track of how many places the decimal has to move. And the sign on the power is the direction it has to move, right? I never remember left and right. Yes.
Now how I know I have to put 1.4?
Of course you do. What did I say before? What do I have said every time? The decimal must move until there's a single digit in front of it. So I must move the decimal until it has a single digit in front of it. So if you thought the answer was 369, if you thought the answer was 14 times 10 to the 9th, you're wrong. Because 14 still has a 10 in it, doesn't it? That 1 means 110. I haven't sucked all the 10s out of it yet. So you have to move the decimal as many places as you have to until there's no other, there's just one digit in front of the decimal. That's what I've done every time. Every time. When? Every time. All right.
I got it.
Here's a little more, so that's not the right answer. Here's a little more interesting problem. And this is as interesting as they get, so don't get freaked out. So you got to multiply those. Move you over a bit. There we go. There we go. Where's that other? I have no idea what there. Oh, it's coming from this screen. Oh, too bad. Ha. So now watch. We know how to do this. Really quick, before anybody says anything, here's a related problem. Forget about that problem for a second. In fact, let me hide it. How would you do this problem?
Multiply?
Yeah, it's all multiplication, right?
Yes.
So you do 3 times 3 is 9. A to the negative 11 times a to the 5th is a to the what?
-6.
Negative 6. I love it, right? Now watch. Now let me show you this problem again. Wee-haw. Do you see how it's the same thing? Except instead of a, I have 10. So 3 times 3 is 9 times 10 to the negative 6 the same way. Right? I have 10, 10, so I just add the powers. When I multiply like bases, I add the powers. So instead of an A, I have a 10, but it works the same way. Of course it does. And do you see how this is still scientific notation? Yes, Jeff. So, how would I write this in decimal form? That's just normal number form. How would I write this in decimal form? Will it be a big number or small number? This thing right here. How do I change that to normal number form? Get it out of scientific notation. It's going to be a very small number, right? In fact, I've got to move the decimal back 6 places. So once to get around the 9, and then 5 more times. Man, I didn't give myself enough room, right? So it's 1, 2, 3, 4, 5, 6. So that's the shortcut. To rewrite negative powers, I just put 1 less 0 in front of the number because that's how many zeros I'll get if I move that many times. So all scientific notation is about how many movements to make with the decimal and in what direction. That's all scientific notation is really about. This is so weird. You can only see my hands and my beard, my little tiny beard. Okay, all right, so anything else about those? Does somebody want, can somebody have like you can always have more long division in your life? Anybody else want more long division problems out there? Okay. Let's do one of those real quick. We know we all love them. We love them. So let's do this. That looks just yummy. That looks just yummy. That sounds so wrong, and I don't care. So let me get another one here. Get up here. Okay. All right, so we've seen this hopefully enough by now. X squared times what is x to the 4th?
X squared.
Yeah, I need 2 more x's to make x4, right? So I'm going to have an x squared there. So then x squared times x squared is, of course, x to the fourth. That's why I put it up there, right? So those always have to be the same thing. X squared times negative 2x squared is negative 2x squared. Now, be careful. Where am I going to put that? Negative 2x squared. I want to line it up with like terms. Holy shit, Jeff. Don't write on your wall. Too bad. Let me stop for a minute. Does that make sense? So I want to show you this because there are a couple on the homework that are like this. When you have see how there's an x squared, there's no x term. So when you multiply this, you're going to want to line up your like terms. Do you guys see that? I'm not going to put that here. That doesn't make any sense. I'm going to line up my like terms. Of course I am, just to be nice to myself. Why wouldn't I? I can only put together like terms. Okay. And then, of course, what do?
Change the sign.
Change the signs. These cancel like they always are supposed to. Bring that down. There's nothing else here. So he just comes on down. He's like, yeah. And then negative x squared plus 2x squared is plus x squared. And then bring down the 1. Is that the glare from the, where's that the glare from? Oh, that's the glare from over there. Okay, I can take care of that. Who needs sunlight? Oh, there you go. All right, one glare gone. Okay, so then x squared times what is 2x cubed?
1.
No.
2x.
Yeah, okay, I love that. That's so weird. You went from the total wrong answer to the complete right answer like that. That was so cool. I need a 2. Okay, I need a 2. I need one more x. Okay, I need one more x. Do you guys see how to put that together? X squared times what is 2x cubed? I need a 2, and I need one more x. Okay, there you go. So 2x times x squared is 2x cubed, just like I created. And 2x times negative 2 is negative 4x, right? I was really evil here. I didn't even mean to be this evil. I didn't even notice how evil I was. And I apologize to myself and to you. Do you see how there's no x term? Okay, I'm going to pretend like you do. See how there's no x?
There's no x.
There's 4, 3, 2, and then no x. That was so mean. I didn't even mean to do that. So I really should have put a 0 there. Remember talking about that? I didn't even realize I had done that. The evil part of my brain just kind of went off by itself. So now if I do, now you can see why I want to do that, because I need to have a place to put 2x times negative 2. I want a place to put negative 4x. Okay, I wasn't trying to be quite that evil. Then I change my signs. Did I lose my, yeah, there he is. My markers just want to stop. They're like, God, no. Change my signs. These cancel like they're supposed to. Bring down the x squared. 0 plus 4 is 4x. Bring down the 1. X squared times what is x squared? So then x squared minus 2. Okay, let me stop for a second. Oh, you can't even see that. You got to pull that away a little bit. There we go. One times x squared is x squared. 1 times negative 2 is negative 2. Line up the like terms. And then, of course, I change the sign. So I just keep doing the same thing over and over until I'm left. How do I know when to stop this crazy shit? I know when to stop when that is a higher power than that. Because then I can't make x squared go into 4x. There's not enough x's in 4x to handle that. So then I just take this. That's my remainder. Over that. Okay. That was a pretty difficult problem, to be honest. There was more to it than I actually intended. So there's 2 things you got to be careful about. If you're missing, like a power is missing, you want to put a 0 there so you have a place to put your like terms. Notice this. If this is missing something, you're going to want to be careful about lining up your like terms, right? So you always want to make sure that what you write down here is like terms with what you put it with. That makes sense. We want to be nice to ourselves. Okay, maybe. So what this means is if I multiply this by this, I will get this. So you could actually check this if you felt adventurous. If you don't feel like it, at least know what it means, right? It means the same thing that division always means. Okay, maybe. And just to remind you guys, there is that video that's up where I have a couple of exponential examples and then a worked out long division example that's not quite this freaky. Okay. All right. So I just want to do a little more today. Any specific questions on anything else before I do a couple things and then let us go? Going to look at the long division more. Good. You need to do it. This is a really difficult example. Right? I actually made it a little harder than I meant to. Not all the problems are like this. This is a more complicated one, but I desperately want you to realize the process doesn't change. It doesn't. What do I need to put there to make that become this, right? What this times what is this? Bam. And then I multiply it, line up like terms, keep going, repeat. Okay. So last thing I want to talk about, somebody's like, no. What's the matter, Savannah? Okay. She has taken away her objection. Okay. So the last thing I want to talk about is, believe it or not, just a little baby step into the next chapter. And this is actually, I didn't even need to say that, but I want to explain what we're about to do. So remind me, this is old stuff, just to get us back in the right mindset. How would you do this? What's that? What's the property? Distribution, yeah. So I would get, what would I get? 4x minus 8. Okay, I'm not even going to wait for you guys. That's old shit. If you can't do that, I don't want to know, because then I'll be very sad. Right? Everybody can do that. You're like, give me problems like that, Jeff. At least you should be. Now watch. So that's old shit. That's old and busted. Let's talk about new hotness. So new stuff is doing that backwards. So what do I mean? What if I wrote down here 6x minus 18? Can you figure out something times something like that? What did somebody distribute to make 6x and 18? So 4x and 8, I can see somebody distributed a 4 because a 4 goes into both. So I want to do distribution backwards. What number was sitting in front of something here to make 6x minus 18? What goes into both of these? What goes into 6x and 18?
6.
6. So there must have been a 6. 6 times what is 6x? And 6 times what is negative 18? 6 times what is 18?
-3.
Yes.
3.
So that is just distribution in reverse. Okay, maybe. Okay, now watch this. So let's look at this one. Okay, maybe that's a little bit too freaky, but oh well. Ax squared minus a cubed x. Okay, this is kind of freaky. But how many a's do they have in common? Both of these terms. How many a's does this guy have?
1,
How many A's does this guy have?
3,
How many A's do they have in common?
1.
1. Yes, they both have 1 A. Do they both have 2 A's? Nope. They both have 1 A. So I can take an A out. Somebody must have multiplied an A in because they both have an A. How many X's do they both have? I mean, how many X's do they have in common? He's got 2
1.
X's. He's got 1. They both have
1.
an X. I love it. So you can take an X out. Totally serious. Serious? What is happening?
It's going to be X.
Yeah, so now watch. If I take an A out, there's no A's left.
Okay. It's going to be X minus A.
Yes, because let me catch up to you. I had 2 X's. I took 1, so now there's 1 left.
Yes.
Minus. I had 3 A's, and I took
A
1 out.
squared. A squared.
And I had 1 X, and I took it out. How do you check yourself? AX times X is AX squared. AX times negative A squared is negative A cubed X.
AQX. I got it. Easy.
Don't say that. Not everybody will agree with you.
I'm joking.
It's always nice when there's an easy part. Now, what we just did is a very basic form of factoring, right? So it's called,
Seriously. Sometimes confused.
I understand. It's called greatest common factor. And I just want to show you, let me see. I promised that was the last thing, didn't I? That's plenty. That's plenty, right? We're pretty much right on track for where we're supposed to be. So I'm not going to push that too much. So the whole next chapter is about factoring. So you might want to go back and make sure you can just remember how to factor numbers all the way down, right? So remember doing stuff like making a factorization tree for 48. Do you guys remember doing stuff like that? So 48, you could do 8 times 6, and that's 4 times 2, 2 times 3, and then that's, get out of there, 4. That's 2 times 2 times 2 times 2 times 3. Ah. Do you guys remember that? I call this finding the DNA of a number. If I broke 48 down all the way, I get this. This is its DNA. When I put that together, I get 48. That's why I call it the DNA. And you're all like, dude, don't bring biology in the middle of this shit. I'm sorry. I just like it. All right, that's plenty. That's plenty. So don't forget, tomorrow is the quiz. It'll work the same way as always. We'll do lecture, and then I'll make the quiz active, and it'll be due later that night. Does anyone have any questions? Need to hang out for a bit?
Yes, I don't get the quiz 6. I don't get
You don't, I'm sorry, you don't want?
my grade. Quiz 6.
All right, let me see. Hold on. Let me take this apart here so it's easier for me to do stuff. Bum, 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 bum. You guys can all see my beautiful pajama pants. Working from home. All right, let me see. Quiz 6. Oh, shit. Let me see. Leave that. Oh. Wait a minute. Quiz 6. There it is. Did you, let me see. So it looks like you did not turn it in on Canvas. I guess maybe you emailed it to me. So this is what I don't understand. You have to upload
I sent it
stuff.
to you on Canvas.
No, it's not in there.
I'm sure for that. I do it on afternoon, not night too.
But I don't know what to tell you. It's not there. So you might have turned it in the wrong place. And where it says quiz 6, it's not there.
I'm gonna send it again now.
Well,
but I'm sure I do it.
Now it's
I did.
late. That's a problem. Let me see if
Believe me, I send it to you in the afternoon. I do it faster. I remember that.
No, all I can see is what I can see. So I don't know if you turned it in the wrong place. That would
No,
actually,
the same one. I submitted. It's 3 pages. I did.
nothing you're saying means anything to me because if I can't see it, I don't know what to
I
tell you.
understand, but
Let me see. I'm trying to see if you turn it. If nobody else has any questions, you guys don't need to hang out here. All right.
it's making me a problem for that.
Say again?
It's gonna be a problem for me.
Well, somewhat. I got to figure out what to do because
I'm sure, Professor. I'm sure for that. I send it to you afternoon. I don't know what is the problem. I
so
don't know.
at the worst, you're gonna have to do a makeup quiz because I can't accept anything now because it's way too late.
That's bad for me, but I did it.
No. I didn't get it. So if you give it to me now, it's late. So I'm gonna have to see about making you a makeup test, a makeup quiz. Unless I can see it here somewhere. Did you send it? I don't see it here. I don't know where you put it, I am, because I don't see it anywhere. Let me see. Yeah, I don't know. So just shoot me an email, remind me about trying to figure out something for quiz 6, okay? I am.
When I push that canvas, they tell me submitting.
But I am. I don't. That doesn't mean anything to me because for whatever reason, it isn't there. That's all that really matters.
They tell me submitting. Already, I submit for you. I submitted
You
for
see
you.
how that I can't do anything with that. I can't do anything with that because,
Okay, what do I have to do?
like I just said, shoot me an email. Say don't forget about a makeup quiz for quiz 6. Okay. That's the only fair thing I can do.
Okay.
Okay. All right. Anybody else have any issues or questions? Everybody else is just sort of either
That's it.
not really here or just. All right. I'm going to close the room up. See you guys later.